Now let's take a look at multiplying two matrices. To multiply two matrices, we have to first look at the orders of the matrices. So the number of columns, so the dimension of A is m by r is the number of columns, must equal the number of rows in the second matrix. So number of columns compared to the number of rows. And the order here matters. Now, once you've established that you can multiply, the dimension of the product will be given by the number of rows by the number of columns. The number of rows is obtained from A, and the number of columns is obtained from B. So first matrix, second matrix. And now, any entry in the product is obtained from looking at row, then column products. So, if I'm looking at the ith row and jth column of my product, I look at the ith row of my first matrix and the jth row of my second matrix, and I multiply corresponding entries. So A I1 times B1j, and then A12 B2j. So we multiply corresponding onward and downward. And then we add those products. So add, all the way down. Let's take a look at an example. So first thing first, let's look at the orders of the matrices. So this is a 2 by 3, and this is a 3 by 2. So these match, so we can multiply. Then we know that the result is going to be a 2 by 2 matrix. So what I'll do first is, since we know that we have 2 rows and 2 columns, I'll just pencil in that we have those entries. So now, let's look at this entry. So this entry is in the first row, first column. So we will look at first row, first column. So let's take 2 times 5, and that gives us 10. 4 times 10 is 40. And then lastly, 3 times 8 is 24. Now those get added together. And now let's look at our next entry. So now we're in the, if we look at this entry, this is the first row, second column. So first row, second column. And we multiply across and down. So 2 times 7, 4 times 0, 3 times 9. Now, we'll look at the second row, first column. So second row, first column. We'll take 6 times 5, 9 times 10, 1 times 8. So 6 times 5, 9 times 10, 1 times 8. Now let's look at the second row, second column. So second row, second column. So we'll take 6 times 7, 9 times 0, 1 times 9. So 6 times 7, 9 times 0, 1 times 9. And so this yields for us 74, 41, 128, 51. Now let's reverse the order of these two matrices. So last time we looked at the reverse of this. So let's do this again, but this time it's a 3 by 2 and a 2 by 3. We can already tell that these are going to result in, or this product is going to be different. We can find the product because the 2 matches, and now we have the 3 and the 3. That tells us the order of our result. So we're going to have a 3 by 3. So now let's look at the first row, first column. So first row, first column. We have 5 times 2 and 7 times 6. Now let's move to the first row, second column. So we will take 5 times 4 and 7 times 9. And now let's go ahead and find the first row, third column. So that will be 5 times 3 and 7 times 1. Now let's move to this second row. So second row, first column will give us the second row, first column. So 10 times 2 plus 0 times 6. Now let's move to the next column. So second column in the second matrix. So second row, second column gives us the second row, second column entry. So 10 times 4, and then 0 times 9. Now let's move to the second row, third column. So 10 times 3, 0 times 1. Now let's move to the third row. So third row, first column will give us 8 times 2, 9 times 6, add them. Now let's move to the third row, second column. So third row, second column. So 8 times 4, 9 times 9. And now, third row, third column. So 8 times 3, 9 times 1. So this gives for us 10 plus 42, 20 plus 63, 15 plus 7, 20 plus 0, 40 plus 0, 30 plus 0, 16 plus 54, 32 plus 81, and 24 plus 9. Now let's look at example 7. Here we have a 2 by 2 and a 3 by 2. So notice the dimensions do not match. So the product is not defined. And then, as we saw in two of our examples, if we change the order of multiplication, we could result in a different product. So we say that matrix multiplication is not commutative.